Alright, this lesson is on irrational zeros. So let's find all the zeros. So that means rational, that means irrational. There might even be complex, but in the next lesson we'll talk about what that means. And then write all answers in the simplest form if you can. So in number one, how I'm going to do this is I'm going to factor it. So think of this as a trinomial. What two numbers multiply to 18? The same two numbers add to negative 9. So it's negative 6 and negative 3. So I have f of x equals x squared subtract 6 and x squared subtract 3. Now, it's in the form of a difference of squares, but the square root of 6 and the square root of 3, they're irrational, hence irrational zeros. So at this point, I'm going to take each factor, make it equal to 0, and solve it. So to solve this, I'm going to add 6, and then I'm going to take the square root. Now, when I solve a quadratic, the answer could be positive or negative. And the square root of 6 is prime. I can't simplify it anymore, and it's an irrational answer. I'm not going to use a calculator and put a decimal there. It's just root 6. I'm going to do the same work here. I'm going to add 3 and then take the square root. Remember, the answer is positive and negative. So when I'm thinking of what are the zeros are positive and negative root 6 and positive and negative root 3. All four are irrational. So we're going to do the work again. We're going to factor this. So 4 times 8 is 32 and negative 33. So what two numbers multiply to 32 and add to negative 33? So negative 1 and negative 32. So I'm going to write down, take out the negative 32 and put in negative 33, put in negative 32 and negative 1. Order does not matter. You'll get the same answer. And then factor by grouping. So the first two have this is to the fourth. The first have an x squared and a 4 in common. And what I'm left with is x squared minus 8. The second one has a negative 1, and I have x squared minus 8. And then they have the same, share the same factor, x squared subtract 8, and what's left over is 4x squared take away 1. Now at this point, I'm going to take each factor equal to 0 and solve it. So for this one, I'm going to add 8 and take the square root. Again, the answer is positive and negative. You might remember that the square root of 8 can be simplified because 8 is 4 times 2. So the square root of 4 is 2, and what's left over is 2. The second one, 4x squared minus 1 equals 0. Again, I'm going to add 1, divide by 4, and then when I do the square root, again the answer is positive and negative. The square root of a fraction, you just do the square root of the top and the square root of the bottom. So the square root of 1 and the square root of 4 is 2, so it's plus and minus 1/2. So if I was listing the zeros, we have plus and minus 2 root 2. Those are irrational. And plus or minus 1/2, that is rational. I know exactly where 1/2 and negative 1/2 is on a number line, but square root of, or 2 root 2 is irrational. I can only estimate it. All right, here we go. Let's factor by grouping here, if we can. So they have an x squared in common, and you have 2x plus 5. What big number? 12, right? And you have 2x plus 5. That's good. So they share 2x plus 5, and we have x squared minus 12. So even at this point, you can understand the first one that comes from here is you're going to, if I was going to, okay, the zeros, I'm going to subtract 5 and divide by 2. Here, I'm going to add 12 and do the square root. So I know that it's positive and negative. So if I add 12 and do the square root of 12, I can remember, okay, the square root of 12 is 4 times 3, right? So it's 2 root 3. Negative 5 over 2 is rational. Positive and negative 2 root 3, irrational. I know exactly where 5 halves is. 2 root 3 I can only estimate on a number line. Again, I'm going to factor this by grouping. So I'm going to take out a 3x squared. And I'm left with x subtract 5. Factor out a negative 4. And you have x subtract 5. So they share x subtract 5. And what's left over is 3x squared minus 4. So what would the zeros be then? So positive 5 is rational. Here, I would add 4. Then divide by 3. Now, when you take the square root of 4 is 2. And the square root of 3 stays the same. It's plus and minus. For right now, I'm going to be okay with that answer. We're going to learn how to rationalize the denominator so that the denominator is not a square root. But for right now, we're going to leave it that way. So again, 5 is rational, and 2 divided by root 3 is irrational. So use the rational zero theorem to be able to factor this out. So think of all the numbers that go into 36. So 1 and 2 and 3 and 4 and 6 and 9 and 12 and 18 and 36. Next, we're going to do division. Positive 1 does not work because it doesn't add up to 0. So we need to pick another number. So I'm going to pick 2. And there it is. So I already know 1, 0, because that's my goal, is positive 2. And it's rational, the rational zero theorem. Now what's left over is x squared subtract 18. I'm going to make that equal to 0 so that when I solve it, you get plus or minus the square root of 18. Irrational. We could also understand this as 9 times 2, so that this would be plus or minus. Now the square root of 9 is 3, and what's left over is root 2. Okay, rational, irrational. Number 6. All the numbers that go into 60. That's huge. Isn't that crazy? The first 6 numbers go into 60 evenly. Then we're going to do synthetic division. And see, does positives add up? No, it doesn't add up to 0. So we're going to pick a number that will work. So you're going to have to test it out. I think 4 works. Then we need another number that works. So I think it's the next number that works is negative 5. But again, you just have to keep testing until the remainder is 0. And then what you're left with is x squared subtract 3. So if I solve that, I add 3, and that's plus or minus the square root of 3. That's irrational. It's real, but it's irrational. So if I list these zeros, the zeros would be positive 4 and negative 5. Those are rational. And then plus or minus root 3, those are irrational. So it's a combination of both. All are real, all would be on a graph. But these you would estimate, and these you'd know exactly where they are on the graph. Create a list. There's going to be an announcement soon over the intercom, and when that happens, I'll shut the video down and then just pick up where I left off. So there's the rational zero list. I'm going to do synthetic division. So 1, negative 5, negative 29, negative 15. So positive 1 does not work. So another number, which one on the list? So I'm going to pick, I know it's negative 3. Now what's left over is x squared subtract 8x subtract 5. Now that's not factorable. So I'm going to solve this by completing the square. You could also do the quadratic formula. So I'm going to add 5. Then I'm going to take negative 8. I'm going to do two things. With negative 8, I'm going to divide it by 2 and square it. So that's negative 4 squared, and that's 16. So 16 I'm going to add to both sides. But when I factor, I'm going to use the negative 4. So how do I complete the square again? So A, B, C. B, take B, divide it by 2 and square it. So add it to both sides. This factors to the same factor repeated, and that number, negative 4, is always going to match. And then 5 plus 16 is 21. So now take the square root to both sides, and it's plus or minus. The square root of 21 is irrational, and then add 4. Now, rational and irrational numbers cannot combine together, so they go beside each other. And now you have all the zeros. So negative 3 is a 0, and we have 4 plus root 21 and 4 take away root 21. Rational, irrational, completing the square. All right, number 8. The list. The only numbers that go into 19. That's a nice number. Prime, 1 and 19. Long division, or synthetic division. 1, 5, negative 25, and 19. Hey, this adds up to 0. That means which number works? 1. What is that? 19. And then what's left over is x squared plus 6x take away 19. Not factorable, so I'm going to solve it by completing the square. What's b? 6 divided by 2 and square it. So that number is 9. So I'm going to go x squared plus 6x. I'm going to add 9. I'm going to add 19, but I also have to add 9 to it. This factors to x plus 3 squared, and on this side is 28. And then when I take the square root, the answer is going to be positive and negative. Now, the square root of 28 is really 4 times 7. So the square root of 4 is 2, and what's left over is 7. And then the last step to get x by itself is to subtract 3. Now I have all the zeros. So first we found positive 1, and then that's rational, and then the irrational are negative 3 plus 2 root 7, and negative 3 subtract 2 root 7. Done. Number 9. All the numbers that go into 36. This one counts up to 4, skips 5 to 6, so it's another one that has a lot of numbers that go into it evenly. Synthetic. 1, 1, negative 21, negative 36. So 1 does not go in it evenly. So the one that does go is negative 4. You'd have to guess, keep trying until you find the one that worked. And what's left over is x squared subtract 3x subtract 9. Again, not factorable. I'm not going to complete the square. That's because b is an odd number, and then you'd have a fraction and so on. So it's x, we're going to use the quadratic formula. So just as a reminder, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this example, a is 1, b is negative 3, and c is negative 9. So when I put this in, big fraction line, let's start. So a negative and a negative makes it positive 3. Negative 3 squared is 9. A is 1, c is 9, negative 9, and then 2a on the bottom. So let's simplify this. I get 9 plus 36 and that's 45. And if you wanted to, 45 is 9 times 5. So the square root of 9 is 3, and what's left over is 5 over 2. And there you go. So what are all the zeros? So the first zero we found was -4. And then the irrational are 3 plus and minus 3 root 5 all over 2. 10. Create a list. 1, 2, 3, 6, and then divide it by 3. So 1/3, 2/3, 3 over 3, and 6 over 3 are already on my list. And there it is. Synthetic division. So that's 3, -30, 71, and 6. Doesn't add up to 0. Positive 1 doesn't work. Actually, the one that works is 6. What is that? -72. What's left over is 3x squared minus 12x minus 1. Now, even though I have an even number here, the a needs to be positive 1 to complete the square, so I'd have to divide everything by 3. It's still not like impossible because you have 1/3 that you'll be like working with. We'll practice the quadratic formula again on this one. So the quadratic formula is -b, so that becomes positive 12, b squared, which is 144, and then 4ac, and then 2a. So we have 144 plus, what we got, 12 over 6. So let's write down the zeros. So 6 worked. I'm not even going to bother. You could simplify it down. I'm not going to judge that right now. So it's the square root of 156 all over 6. That's beautiful. Next, let's talk about Descartes' rule of signs. See, in many cases, the following rule discovered by the French philosopher Descartes is helpful in eliminating possible zeros from a lengthy list. To understand this rule, first we must look at the variation in signs in a polynomial. When a polynomial is written in standard form, a variation in sign occurs when there are consecutive coefficients with opposite signs. So how many variations in signs do you see? So we have from positive 4 to -3. All right, so I'm going to continue Descartes' rule of signs after we're doing a little drill right now. So we'll continue this one after. Next video.